In this video, we are going to cover very important technique of analytical chemistry known as gas chromatography. We will discuss about that what is a gas chromatography, what is principle of a gas chromatography, and how the instrument which is known as gas chromatograph works, how we can analyze a sample using gas chromatography. Gas chromatography is a technique which is used to identify or which is used to single out different kind of molecule in multi-component systems. In simple word, gas chromatography is a technique which is used to identify different types of molecule present in multi-component compounds. Basically, this technique separates different types of compound on the basis of considering different factors like boiling point of compound, like atomic weight of compounds, etc. And on the basis of that, this technique separates different types of molecules in multi-compound systems. And on the basis of that, we can identify the composition or the presence of different components in the compounds. The instrument which is used in gas chromatography is known as gas chromatograph. So now, dear students, let us discuss that how we can analyze a sample by using a gas chromatograph. Before discussing the analysis of the sample using gas chromatograph, it is very important to understand essential component or basic part of a gas chromatograph. Schematically draw a different component or different parts of a gas chromatograph. A gas chromatograph consists of a gas cylinder. The gas cylinder is usually of a gas chromatograph is filled with an inert gas. Inert gas such as helium, etc. Whereas the gas cylinder of gas chromatograph may be filled with nitrogen gas. Nitrogen gas is non-reactive gas, and similarly inert gases are also non-reactive gases. That's why they are used in gas chromatograph as a transport carriers. Transport carriers. They are known as carrier gases. The cylinder of a gas chromatograph cylinder is connected with the part of a gas chromatograph known as gas flow controller. Gas flow controller is based on a device which controls the flow of the amount of the inert gas in a gas chromatograph. This is known as flow controller. So the flow controller basically controls the flow of the amount of the inert or nitrogen gas which acts as a carrier gas, and through the flow controller the inert gas is transported into a region which is usually known as sample holding region of the gas chromatograph. This is known as sample holding region. The sample holding region of gas chromatograph is connected with a device, with electronic device known as injector. Injector inject different types of sample which is may be present in a form of a solid, liquid or gas into the sample holding region. Now, distant, keep in mind that gas chromatography uses this gas as a sample for analysis. In order to convert a sample which we want to analyze into a gaseous form, usually heating setup is used in case if we are using solid or liquid sample. Initially, before injecting into a sample holding region, the solid or liquid sample is converted into a gas and then it is transported inside the sample holding region. So now both the sample which is in a form of a gas is mixed with a sample which is with a gas or with an inert gas molecule. So both of these are mixed up. So after mixing in a sample holding region, after mixing of the inert gas molecule uh, and a sample which is in a form of gas, they are transported into a region, into a part of a gas chromatograph known as column. The column of gas chromatograph operate around 300 degrees centigrade. This is a temperature of a column of gas chromatograph. So it acts like an oven. Usually column of the gas chromatograph column of a gas chromatograph is made up of a steel, metal, or it may be made up of glass. Student, please keep in mind that the column of gas chromatograph is usually is a kind of an empty tube. It is just like a tube, and a tube has a has inside a kind of a different kind of a liquid, or it may be filled with a different kind of a solid, and it so the tube is filled with a solid or a liquid material, and this solid or liquid material is known as stationary. This is known as stationary phase materials. They are basically stationary inside the column or inside the tube or inside the columns. So the role of the stationary phase material is very important. Usually the stationary phase material used in gas chromatography is basically it is silicon grease based liquid, and these materials have a high melting point. They have a high melting point. So the stationary phase material, they play also an important role, okay, in a column. So now after the column, the gas chromatograph consists of a part known as a detector. Sample passing through a column will go to a detector will detect the amount of a different component or different molecule at a different time reach toward the detector. So after that, detector will transfer the whole information to a region which is known as a computer analysis system, and the computer analysis system basically it will interpret computer analysis system will basically interpret the information which is received from the gas chromator from the detector, and on the basis of that computer analysis system will draw a graph which is usually based on retention time, and intensity. And we get a peak from the computer analytical systems, and the graph of which is achieved by a gas chromatography is known as gas chromatograph. So now let us discuss that how we can analyze a sample using a gas chromatograph. Initially, dear student, the sample is incorporated in a sample holding region in a form of a gas. If the sample we want to analyze is in a form of solid or liquid, then in a gas chromatograph there is a heating setup which is based on resistive coil. Resistive coil will heat the sample which is in the form of solid or liquid, and it's transport it or convert it into form of a gas, and then this gas sample is injected in a controlled fashion to a sample holding region. So sample in the form of a gas in gas chromatograph is transported into sample holding region, and the inert gas or nitrogen gas is incorporated from gas chromatograph cylinder through a gas flow controller in a controlled fashion into a sample holding region. Both the sample in a form of a gas and inert gas, both of these are mixed in a sample holding region, and then the mixed gas and a sample are in the form of a gas are transported into a tube which is known as a column. This is a column. So the sample will be transported inside the column. Column will be in a form, is usually in gas chromatography is in the form of tube. So sample in a form of a gas, sample in a form sample plus inert gas will be transported inside the tube of the or a column inside the column of the gas chromatograph. Column consists of a stationary phase material. The stationary phase material in a column is used because it's usually absorb different, like the basically it's absorb, and it's do not allow the different types of the sample or sample molecule or inert gas to react with the boundaries of the uh, column. So they basically control, and secondly they basically and secondly, the stationary phase allow the movement of the complex compound molecules inside the column. So now the gas molecules and inert gas and as well as the sample in the form of a different types of molecules, they will pass through a column. Now interesting point here to notice is that, dear student, we gas chromatograph analyze a complex compounds. They have different types of molecules, their boiling point is different. So the temperature of column is around 300 degrees centigrade. Okay, so as if the molecules have a different boiling point, then the if the molecule having a low boiling point, they will move fast. Similarly, if a molecules have a high boiling point, then they will move slowly because they are not boiled, so they will move slowly. They are, and whereas the molecule with a low boiling point, they will move fastly and they will reach at rapid speed toward a detector. So the graph which we achieved in a gas chromatogram, the first peak of the graph in the gas chromatograph will represent molecule with low boiling point. Similarly, we will achieve different types of peaks in a graph, whereas a peak which is the last peak, it will represent a molecule with a high boiling point, dP. So in this way, the molecule will be transported and they will reach toward the detector, and detector will analyze the molecule on the basis of retention time. Retention time is the time up to which different types of molecule of complex compound they remain inside the column of the gas chromatograph. So if the boiling point of molecule is less, then the molecule will remain for shorter time and the retention time will be less, and they in the smaller retention time will get of those molecules, whereas the molecules which will remain for longer time, then we will get a longer retention time, and the last peaks or peaks with a higher retention time, we will achieve those peaks. So in this way, we basically receive information in the detector, and detector then transport or give the information toward the computer analysis system, and on the basis of that we get a graph between a retention time and as well as the intensity of the molecules present in known or unknown sample. Now, dear student, please note that the detector used in gas chromatograph may be a mass spectrometer. So there are wide range of detectors used in gas chromatography, but the most commonly used detector in gas chromatography is mass spectrometer. Mass spectrometer, and on the basis of using the mass spectrometer, the gas chromatograph is known as GCMS, gas chromatography mass spectrometry. So mass spectrometer will separate different types of gas molecule also on the basis of mass to charge ratio. If you want information about mass spectrometry, please watch our lecture on mass spectrometry. Just keep in mind, it is not necessary that gas spectrograph only detect or collect information only on the basis of boiling point. Suppose if we have molecule with different boiling point, with same boiling point, then how gas we can get information from the gas chromatograph that what type of molecule are these. Dear student, please note that every molecule have an atomic weight. Some molecules are small, some molecules are big in size. Now if both these two molecules have a same boiling point, but still we can detect in detector of gas chromatograph that what type of molecules are these, because the smaller molecule in a molecule with smaller atomic weight will move faster than the molecule with a higher atomic weights. So on the basis of even on the basis of atomic weight or on the basis of atomic mass, we can detect the presence of different kinds of molecules in a complex compound. Students, please note that the peaks which we achieved if we are analyzing unknown compounds, and then in that case the peaks which we achieved with the gas chromatography, we match them with a gas chromatography library, and on the basis of the thorough analysis we can get an information that what kind of complex molecules are present in complex compounds. So in this way, gas chromatography used to analyze different types of complex compounds. So if I conclude, gas chromatography is a technique which is used to analyze or which is used to separate different types of molecules in complex compounds. And on the basis of that, we can identify the nature of a complex compound. We can identify that what kind of molecules are present in the compound which is known or which is unknown. Gas chromatography usually work on the principle of boiling point. different molecules have different boiling point, and on the basis of that we get an information. However, gas chromatography, apart from the boiling point, it may work on the basis of atomic weight of the molecules, in case if the molecules have the same boiling point. In such cases, molecule with a higher atomic weight will have a slow motion, and whereas the molecule with a low atomic weight, they will move faster. And on the basis of retention time inside the column of the gas chromatograph, we conclude, or the gas chromatograph draw a graph which is known as gas chromatogram. And on the basis of the peaks of the graph, we basically analyze different types of compounds, different types of molecules present in a complex compound. So this is all about the gas chromatography.